Welcome students. Let's start with our chemistry class. Today we will do elements, compounds and mixture. That is also a part of matter chapter. We have already discussed that matter exists in three states: solid state, liquid state and gaseous state. Today we will discuss about the matter, that matter broadly classified into two groups, that is the pure substance and impure substance, means the mixture. Pure substance, they are elements and compounds, and impure substance, it is mixture. Now, what are pure substance? Pure substance, the purity word indicate means it is made up of one type of particles. One type of particles means the particles can be atom or maybe molecules. So pure substances are the substances which are homogeneous, made up of only one type of particles, that is maybe atoms or molecules, and they have definite set of properties. Because homogeneous, so they have definite set of properties. For example, if I say iron, gold, silver, oxygen, common salt, carbon dioxide gas, magnesium oxide, all these are what? These are pure substances because they are made up of only one type of particles. Like iron made, if I will think about the pure iron, then it is made up of only iron particles, means iron atoms. Now next, if I think about silver, then it is made up of only silver atoms. A silver bar, a pure silver bar made up of only silver particles. Okay, if I think about common salt, pure common salt, no impurities are there. Then common salt, sodium chloride, is consisted of sodium chloride molecules. Water, pure water consists of only water molecules. No other molecules are there if the water is pure. So it means a pure substance consists of only one type of particles. Maybe atoms when it is element, or maybe molecule when it is compound. And they are homogeneous. Homogeneous means same composition throughout and same property throughout. So it means if I will take common salt or I will take iron, then what will happen? It has the same property throughout and same composition, is made up of only one type of particles, so same composition. So that is the pure substance. So in just we can say that pure substance are the substances which are homogeneous, contain particles of only one type and has definite set of properties. Example, they may be elements or they may be compounds. When they are elements, for example, iron, silver, oxygen, compounds like sodium chloride, carbon dioxide and magnesium oxide, or maybe water molecules, you can say. Now we will come to the element part. Element. Element. What is an element? Element, you know that gold an element, silver an element, iron, oxygen, nitrogen, carbon means coal, and carbon, sulfur, phosphorus, all mercury, all these are what? These are elements. These are what? These are elements. It means elements are what? Pure substance, because pure substance categorized into two: elements and compounds. So elements are pure substance made up of only one kind of atoms only, and which cannot be broken into two or more simple substance by any physical or chemical means. Means physically you cannot divide the silver or iron into simple substance, or neither chemically you can divide silver, platinum, gold into the simple substance. So elements are what? Pure substance made up of one kind of atoms only, and which cannot be broken into two or more simple substance, neither by any physical mean or nor by any chemical means. Now how many elements are there in nature? 118 elements are there. Okay, and 118 elements are there, and some elements are, what will happen, they won't give the harmful radiations, and we call them normal elements. There are 82 normal elements, and some of the elements are there which gives harmful radiations, and they are known as radioactive elements. They are radioactive elements. So there are in total 36 radioactive elements are there, and 82 normal elements are there. You have heard about the radium. So radium is what? A radioactive element. Any other radioactive element which you know? Anyone? Okay, think. I'll not say. So, and normal elements. 82 and 36 are the radioactive elements. Now next one is the occurrence. Where these elements are present. These elements are present almost everywhere. Within the earth crust, within the atmosphere, these elements are prepared. Generally, artificially elements are not prepared, but nowadays artificially by radioactivity, by radioactive method or by radioactivity, even the elements can be prepared. In the nature, radioactive elements in the nature, the naturally occurring elements are present mainly in the earth, and oxygen is the most abundant element in the earth crust. And after that, it is the silicon. Oxygen is near about 46.43%, and silicon is about 27.7%. And then aluminium, iron, and calcium, other elements are there. Now, by radioactive mean, the elements can be, one element can be converted into the another element, like uranium. What happens, a radioactive element is there, and by radioactive mean, by radioactivity, it can be converted into another element. In the same way, radium, so it can be converted into another element. Now next is that elements occur as single atom, like iron, copper, carbon, so they are monoatomic. Some of the atoms of the elements are present in with two atoms, diatomic molecules. Actually, they are molecules: oxygen, nitrogen, and O2, N2, H2. They are what? They are also the elements, but two atoms are there within them. More than two atoms are there. For example, ozone, phosphorus, and sulfur. So they are polyatomic molecules. They are polyatomic molecules. So they are single atom, monoatomic, they are diatomic, they are polyatomic. Now next is that elements can be classified as metals, non-metals, metalloids, and noble gas. Elements can be classified as metals, non-metals, metalloid, and noble gas. Okay. Iron, calcium, gold, mercury, all these are what? Metals. While hydrogen, oxygen, carbon, sulfur, phosphorus, all these are non-metals. Metalloid, boron, silicon, germanium, arsenic, antimony, bismuth, cadmium, all these are what? All are metalloids. And noble gas, helium, neon, argon, krypton, xenon, radon, all these are noble gas. You have heard about the noble gas. Now first I will discuss about metals and non-metals. Metal, if you think that iron is a metal, silver is a metal, but carbon is a non-metal, sulfur is a non-metal. So when it is a metal, first whenever a metal is there, then how will you identify first that this is a metal, this is a non-metal? Generally we think about the luster, means shiny appearance. So metals are lustrous. Lustrous means they have some shiny appearance. So they are lustrous. While non-metals are not lustrous. Like carbon, any kind of luster is there? No. But some of the metals, non-metals are there. Exception is there, like graphite, iodine. they are lustrous. Next one is that metal, like all silver, gold, they are malleable. Malleable means can be beaten into sheet. Aluminium foil, you know, from aluminium, so thin foil is prepared. Gold foil, silver foil, all these are prepared. It means they are malleable. Malleable means they can be beaten into sheet. But non-metals cannot be beaten into sheet. Suppose carbon, you will hammer it, what will happen? It will not be converted into sheet. Instead of that, it is brittle and it will break down. Next is that ductility. Metals, wires can be drawn from the metals. Means gold wire, silver wire, copper wire. You have heard about this. But non-metals cannot be converted into the wire form. Means they are not ductile. But nowadays carbon fibers are prepared. Carbon fiber, that is the exception. And malleability and ductility, metals generally are malleable and ductile. Exception is that zinc. Zinc is neither malleable nor ductile. Their boiling point, melting point is very high. If you want to melt silver, iron, then you have to give tremendous amount of heat. At a very high temperature, they will be converted into the molten state. But if non-metals are there, then compared to the metal at a very low temperature, they can be converted into the molten state. Density. If you will take metal in your hand, you will feel that it is very heavy. It means metals are heavier while non-metals are not so heavy. Conductivity. Metals are good conductor of heat as well as good conductor of electricity. You know, silver is the best conductor of electricity. But still silver wire is not used in the field of electricity. Why? Because it is very costly. Okay, but silver is the best conductor of electricity. And non-metals are bad conductor of heat and bad conductor of electricity. But graphite is the exception. Graphite and carbon fiber, they are good conductor of electricity. That is why they are used for making, that graphite is used for making electrodes. Generally, metals are present in the solid state. Metals are in the solid state except mercury, which is in the liquid state, and another is the gallium. Gallium also room temperature, it is in the liquid state, and mercury, it is in the liquid state. Non-metals are generally in the liquid or gaseous. Generally in the gaseous state, few are in the solid state also. For example, in the solid state, carbon, sulfur, phosphorus. So they are in the solid state. Gaseous state, oxygen, nitrogen. So they are in the gaseous state. And liquid state, only bromine is in the liquid state. So there is one metal which is in the liquid state, that is the mercury, and one non-metal, that is the bromine. It is in the liquid state, and under uh, a little bit high temperature, gallium is also in the liquid state. So this is about metals and non-metals. And according to electronic configuration, what are metals? The metals are the sub-elements, atoms of the elements which has either 1, 2 or 3 electrons in the outermost cell. Then they are metals. And according to electronic configuration, non-metals means the atoms of the elements which have either 5, 6, 7 electrons are there, then they are non-metals. Now next one is metalloid. What are the metalloid? Metalloid means elements which exhibit the properties of both the metals as well as non-metals. Then they are metalloids. Means sometimes they behave like metal and sometimes they will behave like non-metals. So they are metalloids like boron, silicon, germanium. All these are metalloids. Next one is the noble gas. Noble gas are also known as the inert gas. Inert means lazy. So they are noble gas, actually they are least reactive. They are unreactive or inert and occur in traces in the atmosphere. That is why they are known as the inert gas, rare gas or the noble gas. Noble gas or inert gas because they are unreactive or inert, and rare, why? Because they are present in trace in atmosphere. So this is all about elements that elements classified as metals, non-metals, metalloids, and noble gas. And characteristics of the elements, I said to you, they are pure substance made up of one kind of particles which cannot be broken into two or more simple substance by any physical or chemical means. Okay. Next is that we will elements completed. Now I will discuss about the compounds. What are compounds? Compounds are again pure substances. They are made up of two or more elements. They are made up of two or more elements, but they combine chemically in a fixed proportion. They combine chemically in a fixed proportion. And they, after that, they converted into the molecular state. Okay. They converted into the molecular state, means compounds are made up of one type of particles and those particles are molecules and can be broken into simple substance by only chemical means, not by any physical means. For example, suppose water. Water is a pure compound. It is made up of hydrogen and oxygen, two elements combined chemically in a fixed proportion. Means fixed proportion means 2:1 by volume, or if I will consider about weight, then it is 1:8. Hydrogen and oxygen in water, they are present in the ratio 1:8 by weight. Okay, then it will give you H2O. Means 1 part by weight of hydrogen when combined with 8 part by weight of oxygen, then it will form water. So a compound is a pure substance. It is made up of two or more elements, like here in water, that hydrogen and oxygen combined chemically in a fixed proportion and then form water. Now, if I want to break the water into hydrogen and oxygen, just I will think that I will pick hydrogen molecules or I will filter it. I can separate hydrogen and oxygen. It's not possible here. What you have to do to separate water into hydrogen and oxygen, I think you know, you have to carry out the electrolysis process. Means by electrochemical mean, that is a chemical process, or that is a chemical mean by which I can separate water into hydrogen and oxygen. So compounds are pure substance made up of two or more elements combined chemically in a fixed proportion, and they cannot be broken down into simple substance by chemical means. Sorry, by they cannot be broken down into simple substance by physical means. They can be broken down into simple substance only by chemical means. Now characteristic. Characteristic we will discuss considering a pure compound, for example water, or suppose sodium chloride. Sodium chloride, common salt, water, pure water, that is also a compound. What I say is that they are homogeneous because water as well as common salt both are homogeneous. Compounds are homogeneous. Water and sodium chloride also compound because they are homogeneous. Homogeneous means their properties and composition is same throughout the bulk. Whatever be the source for the preparation of the water, or whatever be the source of water, maybe you are taking the water from the river, or maybe you are taking the water from the sea water, whatever be the source, it is, or if it is pure, it is homogeneous, means it is its composition and its property is same throughout. Now it is made up of two or more elements combined chemically in a fixed proportion. For example, water consists of hydrogen and oxygen. Sodium chloride consists of sodium and chlorine. And if any other, suppose glucose, C6H12O6. This is also a compound which is consisted of three elements, that is carbon, hydrogen and oxygen in the fixed proportion, that is 1:2:1 ratio. Means one part of carbon combined with two part of hydrogen and one part of oxygen, then you will get this C6H12O6. Okay. And if I will consider the weight, then they are in the ratio 6 into carbon each atom 12 gram, hydrogen 12 atoms 12:1, and oxygen is 16 into 6. So ratio is what? 72 is to 12 is to 96. 6 is to 1 is to 8. One is 6 part by weight of carbon combined with 1 part by weight of hydrogen and 8 part by weight of oxygen, then that will form glucose molecule. It is according to the weight and it is according to the number of atoms. The number of atoms, their ratio are 1 is to 2 is to 1, and according to the weight, the ratio is 6 is to 1 is to 8. So that is fixed. Always whenever 6 gram of carbon combined with 1 gram of hydrogen and 6 gram of oxygen, then it will form the glucose molecule. In the same way, if I will think about the water, then according to the number of atoms, if I will think number of atoms, then 2 atoms of hydrogen combined with 1 atom of oxygen, then it will form water molecules. It means they are in the ratio of 2 is to 1 according to the number of 8 atoms, and according to the weight, what is the ratio? 2 atoms of hydrogen weight is 2 gram, and 8 atoms of oxygen, sorry, 1 atom of oxygen weight is 16 gram. So the ratio is what? 1 is to 8. I think this point is clear to you, all of you, that elements combine with each other in a fixed proportion, then they will form the compound. Third is that constituents do not retain their original property. In case of a compound, whenever a compound is formed by whatever the elements, the new properties are developed. Like for example, water consists of what? Hydrogen and oxygen. But the property of water is totally different from hydrogen and oxygen. I'll explain to you. Hydrogen, it is a gaseous substance. Physically, you see here, hydrogen at room temperature, it is a gaseous substance. Oxygen also in the gaseous state at room temperature. And water exists in the liquid state at the room temperature. Okay. Second thing is that hydrogen is combustible. Means it can burn with a pale blue flame. Oxygen, it is a supporter of combustion. But you know, water, neither it support nor it will catch fire. Instead of that, whenever fire burst out, then what you will do? You will throw water to extinguish the fire or to put off the fire. It means water is used to put off the fire. Means water is neither combustible nor supporter of combustion. Instead of that, it will put off the fire. So property of water, chemically even, the property of water is totally different from hydrogen and oxygen. It means within the when compound is formed, the elements by which it is formed, the properties of those elements cannot be retained within the compound. New set of properties are developed. Hydrogen, combustible in nature, a gaseous substance. Oxygen, supporter of combustion, it is also a gaseous substance. While water, it will extinguish the fire or put off the fire, and it is liquid at room temperature. So property of water is totally different from hydrogen and oxygen. Again, if I will think another example, that is suppose sodium chloride, common salt, all of you are familiar with that. Sodium chloride, when element sodium and chlorine combine chemically in a fixed proportion, then it will form sodium chloride. Sodium metal. Okay, sodium is a soft metal, and it is not white in color, little bit yellowish tinge is there, and it is poisonous. If you will take sodium metal, then the chances that after some time it will create problem to you. Chlorine, a gaseous substance which is greenish yellow color gas, and along with that it is also poisonous. But sodium chloride is poisonous. Common salt, poisonous? No. Daily you are with your, when you are taking salad or when you are preparing vegetables, at that time you take salt, common salt you are eating. Okay. So the thing is that it means the property of sodium chloride is obviously different from sodium and chlorine. That is why we are taking along with our food the common salt. While sodium and chlorine you can't, because both are poisonous. And color of the sodium and the color of the chlorine is totally different from sodium chloride. Color is different from sodium chloride. It means these two things proves that by these two I can say that the properties of the elements are totally different from the compound which forms the compound. So the elements cannot retain their property, or their original properties cannot be retained within the compound. The property of the constituents cannot be retained within the compound. Next is that components cannot be separated by physical means. We cannot separate the components of the compound, means by which they are formed by physical means. Like for example, again take water and sodium chloride. I want to separate water into hydrogen and oxygen. Just by picking hydrogen molecules, oxygen molecules, or by heating at a very low temperature, it's not possible to separate hydrogen and oxygen from water. The water can be separated into hydrogen and oxygen by electrolysis method, and that is known as electrochemical mean. So by chemical mean, hydrogen and oxygen can be separated. In the same way, sodium chloride and sodium and chlorine can be separated. When electricity is passed through sodium chloride solution, then sodium will be separated out and chlorine will be separated out. So we can say that we cannot separate the components of a compound by physical means. The components of the compounds can only be separated by chemical means. Now there will be always change of energy when hydrogen combined with oxygen forms water, or sodium react with chlorine forms sodium chloride. Then at that time, since chemical change occurs, so what will happen? Either the energy will be released or energy is absorbed. So these are the points related to the properties or characteristics of the compound. First, they are homogeneous, made up of two or more elements combined chemically in a fixed proportion. Constituents of the compounds cannot retain their properties, and components of the compounds cannot be separated by physical means. They can be separated only by chemical means. And formation of compounds involve energy change. Either energy will be lost or absorbed during the formation of compound. So this is all about the compounds. This is all about the compound. Okay. Now next one is the what? Mixture. Till now we have discussed about the pure substance. That is element and compounds belonging to the category of pure substance. And mixture is what? It is not a pure substance. It is actually impure substance, because it is made up of two or more elements or compounds, or maybe both element, one compound, or one element, two compounds, two elements, one compound. When combined physically, or you can say mechanically, in any proportion without any chemical change, then the mixture is formed. Mixture is impure. Why? Because it is made up of two or more elements or compounds, or maybe both. When they combine physically or mechanically in any proportion without any chemical change, then what will happen? The mixture is formed. And in the mixture, the components retain their property. For example, I want to make a mixture of copper and iron. I will take 2 kilogram of copper and 1 kilogram of iron. Then they are in the ratio 2:1. But the mixture is there of copper and iron. In, now if I will take 1 kilogram of copper and 3 kilogram of iron, then also I can make the mixture of copper and iron. Now they are in the ratio 1:3. So in a mixture, the ratio of the components by which they are formed, that is not fixed. Another example I am giving you, the sugar solution. Sugar solution is a mixture where sugar is mixed with the water. You take 1 gram of sugar and 100 gram of water. It means it is in the ratio 1 is to 100. Then also sugar solution is prepared. Or you can take 20 gram of sugar, 100 gram of water. At that time, they are in the ratio 20 is to 100. That is equal to 1 is to 5. So that is also a mixture. And what you have to do, you have to just mix up. Mix the sugar with the water, add sugar to the water, stir it. The sugar solution is prepared. You don't have to carry out any mechanical process, chemical means neither you have to heat nor you have to pass electricity like that. So physically they are mixed together and mixture is prepared. Now in the mixture, the components by which it is formed, they can retain their property. The best example of the mixture is the air. Air is a mixture. Air is the best example for the mixture. Air is made up of number of gases, that is it's made of nitrogen, oxygen, carbon dioxide, water vapor, and inert gases and dust particles. All these are present within the air. Now air is a mixture. Why? Because first thing is that it is made up of number of components, and these components means nitrogen, oxygen, carbon dioxide, they combine in any proportion, means their composition is not fixed. The composition of is air is variable from place to place. Suppose you will go to the industrial area where number of industries are there. Their percentage of carbon dioxide is not 0.03%, it is more than that. Okay, but if you will go to a rural area, village area where forest is there, or maybe there, what will happen, the concentration of carbon dioxide is near about or maybe little bit less than 0.03%. In the same way, if you will go to the desert area, the percentage of carbon dioxide, the percentage of water vapor means humidity is less, and you go to the coastal region like about Calcutta or Bombay or Chennai, where what will happen, the humidity or the percentage of water vapor is more. It means this supports that, first this point supports that air is a mixture. Why? Because the composition of the constituent is not constant, it is variable, it is not fixed, so it is a mixture. And second thing is that the components can retain their property. Like for example, in air you will get the property of oxygen, you will get the property of carbon dioxide as well as nitrogen. For example, oxygen support combustion, air also supports combustion. Oxygen supports combustion, air also help in combustion. Carbon dioxide, we know that carbon dioxide turns lime water milky. You pass air through lime water, even air will also turn lime water milky. It means the property of both oxygen and carbon dioxide present in the air. In the same way, property of nitrogen is also present in the air. Nitrogen is present in the air. Now next is that property of water. How will you identify the water? When moisture is passed through this copper sulfate, anhydrous copper sulfate, then its color will change from white to blue, and it will become from powdery state to crystalline form. In the same way, if moist air nearby the coastal area, if I will pass through the copper sulfate, anhydrous copper sulfate, then its color will change from white to blue, and it will become from powdery to crystalline form. So air is a mixture because the components of the air, that is the carbon dioxide, oxygen, water vapor, variable. It will change from place to place. And second thing is that the components retain their property. Like oxygen retain its property even in air. Carbon dioxide property is also present in air. Water vapor, nitrogen, the property of all these components are present in air. And next is that they can be separated by physical means. Like if I want to separate nitrogen, oxygen or carbon dioxide from water easily, from air easily, they can be separated out. How? If air is passed through potassium hydroxide solution, caustic potash solution, then what will happen? Carbon dioxide will be absorbed by caustic soda solution. Air is passed through caustic soda solution, then carbon dioxide will be absorbed, so carbon dioxide separated out. Now what is left behind? Nitrogen and oxygen. Now liquefy the air, okay, under high pressure and low temperature. Then both nitrogen and oxygen will be converted into the liquefied form. Then this nitrogen and oxygen which are in the liquid state, now I will heat little bit. Then first the nitrogen will be separated out because its boiling point is low, and then after that oxygen will be separated out. So in this way all the three components, nitrogen, oxygen and carbon dioxide, can be separated out from air. So you can say that the components can be separated by physical means in case of air. So air is a mixture. So the properties or characteristic of the air is that air, it is impure, made up of two or more elements, combined physically in any proportion without any chemical change, and the components retain their property. So that is all about the mixture, and air is a mixture, and you can support that why air is a mixture by giving all these reasons. Now mixture, I said to you, the mixture made up of maybe two elements, for example copper and zinc. The best example, all the alloys. Alloy made up of two or more metals are there. So alloy brass, bronze, stainless steel. So they are the example of the mixture where elements, number of elements are there. Example of compound and compound, any solution like salt solution, sugar solution, that is the example of what? A compound and compound. Another example is where the two elements and one compound is there, that is the example gunpowder. Gunpowder made up of sulfur, charcoal and potassium nitrate, where sulfur and charcoal elements are there and potassium nitrate is a compound. So it means a mixture is made up of either two elements or two compounds, or maybe both are there. Now mixture can be homogeneous mixture or maybe it is a heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. Homogeneous mixture, the example is suppose the salt dissolve in water. So that is homogeneous mixture. Salt in water or mixture of oxygen and carbon dioxide, that is also homogeneous. Or alcohol and water. Alcohol with water, homogeneous. Heterogeneous mixture, oil with water, heterogeneous. Or sand dissolve in water, that is heterogeneous. What I said to you, salt, homogeneous. Suppose one example just I am writing, salt plus water. So salt completely dissolve in water from homogeneous mixture, and then sand mixed with the water, then it is heterogeneous. It is homogeneous means it is uniform mixture. The mixture is uniform. The constituents are mixed uniformly. Uniformly means suppose you mix salt or salt with the water, and after that you will take you will test the salt solution from the bottom of the glass, or you will take the salt solution test from the top of the glass. The test will be same. It means it is uniform. Mixture is uniform. But when you will mix sand and water, somewhere you will see sand particles are more. Somewhere you will observe that the sand particles are less within the mixture. So here the constituents of the mixture are not uniformly mixed. Here the properties and composition is same throughout the bulk or throughout the mixture. But here it is not same throughout the mixture. Properties will be same. Full mixture, same property you will get within the full mixture. But here you will not get the same type of property within the full mixture. I said to you just now, somewhere the sand particles will be more, somewhere it will be less. Then what will happen? It will not be same throughout the bulk. But in this case, the same test you will get. So it is that properties are same throughout the bulk. There are a few examples are there of solid homogeneous mixture. I said to you alloy, brass and bronze, solid homogeneous mixture. Brass is made up of copper and zinc. Brass is a mixture of copper and zinc. Brass metal, I think you know brass utensils. So what will happen? Can you say here copper is here, here zinc is here? No, you can't say. Stainless steel. Can you say where is iron, where are the carbon particles? In case of stainless steel, no. So all the alloys are a mixture of homogeneous mixture of solid and solid component. And a solid and solid heterogeneous, suppose I iron mixed with the sulfur. Sulfur yellow in color, iron gray in color. Easily you can say these are iron particles, these are sulfur particles in the mixture. So it is heterogeneous. Next, salt solution or iodine in alcohol, that we call tincture. Both are the homogeneous mixture, but it is a mixture of solid in liquid. Solid in liquid, salt dissolved in water means salt is solid, water is liquid. Iodine is solid, alcohol is liquid. So that is a mixture. Now when sand dissolved in water, then it is a heterogeneous mixture. Liquid homogeneous mixture is, what is the example? Alcohol when dissolved in water, that is a liquid mixture. And oil in water, that is the liquid but heterogeneous, because oil will not mix with the water, it is immiscible mixture. And all the gaseous mixture are homogeneous in nature. Gas mixed with the gas, because they will diffuse completely, they will intermingle with each other or intermix with each other in such a way that you cannot identify whether this is oxygen gas, carbon dioxide, nitrogen, what type, which gas is there. So they will be completely mixed with each other, so they are always homogeneous mixture, gaseous mixture. This example is the air. So this is all about your mixture. I think now element, compound and mixture clear to you, all of you. Now by yourself, you will find out and think that what is the difference between compound and mixture, and how air is differ from water. How air is differ from water. I have explained you everything about the element, compound and mixture. Now I think that easily you can identify whether the given substance is an element or a compound or a mixture with the help of its characteristic properties. And you can easily differentiate the compound and the mixture, and you can easily find out how air is differ from water.